consider priority. Also, you need to consider cost. And also, you need to consider when you restart the process, how long it will take to resume the process. So you need to consider such several criteria to decide the victim process. So these are the list of the criteria that you can use when you decide the victim process. Priority, how long, and resource, and need, and how many processes will to be terminated, and the interactive or batch process, you can consider that. Then the counter. Nowadays, many of the operating systems will not use each of the approach. In case they need to use such a deadlock, the management, they can combine the prevention, sometimes the part of the prevention. For example, the database system uses serialization to avoid the circular way for the serializable transaction, and so on. Then they combine the two of them, some of the approach. However, the current operating system does not use nowadays such a prevention or the avoidance or detection. Instead, they ignore the deadlock, which means even though fighting each other in this classroom to get the resource or to get the item, the professor or instructor ignore such a thing. Why? All the solutions that we discuss here, for example, prevention, many of them are not practically possible, right? Some of them are possible, not always. And avoidance detection used what? Banker's algorithm. Banker's algorithm, as you can see, worst case is the n squared, which means because we are using the graph. So from the graph, eventually, we'd like to find such a circular way. It's the graph, the theory graph operation, you need the n squared, the brute force. It's an NP-hard problem. So most of the such algorithms are very expensive, so it needs a lot of resources. It costs a lot. So instead of resolving or avoid such a problem, let them go. Let the process use whatever the request, operating system, the grant. Then in case something problem, who is in charge of? Operating system even is not the responsible for addressing the deadlock problem because we need to detect which one is a victim. It takes some time. Instead, operating system let application program, application user be in charge of the resolving the deadlock, which means that is the reason you are doing a lot of control C. Okay, that's the interrupt signal. That's the stopping your process. For example, infinity loop or something, the deadlock situation, you need to kill the process or right click and forcefully stop or the kill signal or control C. From time to time you are doing such a thing because operating system will not be in charge of managing the deadlock situation. It's a very costly. It's a very expensive operation. But some of the application, like the for example database, has something, the algorithm to make the transaction serializable and so on. But the current operating system ignore such a deadlock situation. Okay. That's the end of the chapter 7, and also that's the end of the first half of the operating system, which is the process management. As you have seen, and also as you have learned from your project, the 1 A and B, the process is almost everything of the operating system. So, for example, if you are developing new operating system, you need to start to develop first process, which is the kernel. You need to design the kernel and compile and make the kernel the program. Then from the kernel process, the kernel has several important functionality like the thread, kernel thread. You need to create, and each thread corner thread has the certain responsibility, like the swap or the paging or the schedule, and so you are going to add such an algorithm to that. So all of them are based on the process. So process is the most important resource and data structure when you design and develop the operating system. That's the reason we spend almost the 2/3 of the semester to discuss about the process. Hopefully you learned a lot of things from the lecture and your project. Then next part, we are going to skip the couple of the chapter, which is as we discussed the beginning of semester. So we are going to cover the 3 main parts of the operating system. One is the process management, another one is the memory management, and third one is the I/O management. The 3 parts. So we did the first half, the process management. The second part is the memory management, but we are going to skip because of your second project. So second project, you are going to develop the file system. So first we are going to cover the chapter 10. So we are going to skip the 2 chapter memory management. Then instead we are going to start the I/O management first. Then go back to the chapter 8 and 9 for the memory management at the end of the semester. So what's the size of your SSD hard disk drive? 256. So what is the currently price of the SSD? 256. Well, 1 terabyte. Is there anyone who has the 1 terabyte? You have the HDD. Anyone? 1 terabyte. How much is that? And I mean the SSD. And no one? I think if you go to the Best Buy nowadays, so it's around 300 or 400 bucks. It was every semester when I'm teaching this chapter, I need to check the price of the SSD and hard disk drive. It's getting cheaper and cheaper, but it's not drastically changing. It's like the stabilized nowadays. It was the 1 gigabyte, the 1 gigabyte was around $1 a couple of years ago. It's $1 per the gigabyte for SSD. But nowadays is the gigabyte is I think around it's okay. 1 terabyte is 300 megabyte at 300 bucks nowadays. Then, which means 1 gigabyte it's a 30 cent, 40 cent. It's 30 to 40% cheaper than the couple of years ago. So a lot of things has been changing for the I/O management. So when we talk about the I/O devices, what kind of I/O we have? Except even the CPU and memory can be considered as the I/O devices, but we separate the discuss about the processor and the memory. All the other devices are peripheral device or input and output device. So I/O devices, because it is true when we are using any part of the computer, it's based on how to input and output transfer the data. So we can consider such a thing as the I/O devices. Okay, then the I/O devices. What kind of I/O devices we have? Like the screen is the I/O device, and mouse, keyboard, and many of them are related to human and the computer interaction, HCI also. However, it is true, most I/O happen from our storage. Okay, so that is traditionally we have used the hard disk drive. Hard disk drive has a lot of mechanical operation. Is there anyone who opened the cover of the hard disk drive? Anyone? What happened when you open? What can you see inside? It's nothing but the disk. Okay. Why do we have the disk to store the data? Why? Why? Have you ever thought about why it's always disk? Why it's not like the square?
We can access the location.
Yes?
So that we can access the locations of the disk.
Yes. So because at least any types of the I/O device, so I/O peripheral, it needs to understand at least 0 or 1, on and off. Okay? To do that, so if you make the whole, even though you can use the paper to represent the binary data by punch, okay? You can represent it. You can convert any character to the ASCII code. Using the ASCII code, you can represent each letter as using binary number. Then using the whole punch, you can represent such a binary number. Can be same thing in any type of media. But if we have the square type of the media, it is very hard to read. So which one read such a 0 or 1? Using header. There's a header and send something in the light or whatever. Then if there's a hole, it's 1. It's not, it's close, it's a 0, something like that. So to speed up, best way is we rotate the media. When we rotate, it will be circular fashion, right? So because of that, most of such a media is the disc style. Okay, CD is the same thing, DVD is the same thing. Okay, then we have the disc arm. That at the tip of the disc arm we have the header. Okay, then by rotating and by moving the arm, we can finally read the data. That is the organization, mechanical organization of the hard disk drive. So then, how many disks can you see when you open the hard disk drive? It's one? Actually more than that. It's actually called a platter set of the disk inside. Even though it's very thin inside, why don't you open? So bring your laptop. I can open for you. So you are using SSD. That's the next topic. So it is a platter. So disk arm is kind of set and moving together and read the data and so on. Benefit. We have been used the hard disk drive a lot for a while. Even still used. What is the benefit? Cheap and so the large amount of data. So because of the still use, even though I will talk about that, the competition with the SSD, right now somebody thought SSD will cover the use of the hard disk drive soon, but nowadays even the hard disk drive is bounced off and it's faster and getting cheap. It's much cheaper than the SSD, so many of the laptops still use the hard disk drive. But problem, what is the problem of using the hard disk drive? Which means, so there is a little tiny gap between the surface of the platter and the head, right? It's too far, it will be thick. So very little tiny gap. So if you, it's not hard disk drive, the throw that maybe touch, okay, the surface. Then if accidentally head touch the surface of the platter or space, it will be scratch. So scratch is the most 99.99, the problem of the hard disk drive. If you lose some data from the hard disk, you probably encounter such a problem. So in my case, I stored all I got the digital camera first time 1999. It was really expensive, and if I take the 24 photo using the digital camera, all my battery was gone. So really, it's much more expensive than the. But I stored all those digital photo in the hard disk drive. Several years later, some of them are corrupted, and because of such a scratch. So scratch is one of the biggest problems. Some of the laptop has something reliable, durable. So even though you throw, it protects the hard disk drive, but mostly that is the problem of using. Then nowadays we are using SSD, solid state disk. What is the main difference between the solid state disk and the hard disk drive?
Nothing moves inside of it.
So if you open, I'm not sure, I never did, but if you are able to open the SSD, what do you expect? So a lot of chip. It's based on memory chip. Especially there are different types of such a SSD, but it's NAND, NAND chip, the memory chip. It's mostly the memory is volatile, which means without power you lose the data. That's true, but some types of the memory you can keep the data. It's not really forever, and 100 years, maybe 200 years later, you will lose the data. But I don't think that you live longer than 100 years, right? So you may keep the almost permanently such a data even without the power. That is the idea. It's a memory chip, nothing but a memory chip. Inside you can combine the several memory chips for the higher the space, the storage of the SSD. So it's totally different, which means there's no rotating, there's no moving on. You don't have to find the location. Instead, memory is nothing but what? Addressing. If you know the address, so you can just get the data. There's not absolutely, almost 99.99, and there's no latency, delay time, comparing to the hard disk drive. Hard disk drive is a physical movement. It causes the problem, it takes a time, but this one, SSD, is a memory. Using address, you can just get the data, and it's durable and fast, and problem, expensive. So people believe the bottleneck of the computer system was the hard disk drive. So if the CPU is very fast, memory is fast, but the hard disk drive where data is stored is so slow. So that is a bottleneck. Even though you have the fast media, the processor and the memory, overall processing will be slow because of this bottleneck. So people believe the SSD will restore the cover the old use of the hard disk drive because it's fast, but it's still expensive, and it's very good for the lightweight, the computer system like the laptop or cell phone. But still, the bottleneck is not the only that the storage, secondary storage part. Even though we are using the SSD, still the overall processing is slow because of the application or the management, the operating system issue. So at the time, we do not get the benefit of the SSD. Still slow. So we don't have to waste the money. So hard disk drive, even nowadays, hard disk drive is getting cheaper and getting faster. They reduce such a latency. So we will see what kind of latency. So I believe personally, both SSD and the hard disk drive will continue. But eventually later, for example, the Samsung, I think last year, they have released the 128 something terabyte size SSD also. It's a huge size, right? It's a 10,000, 20,000 the US dollars, but their specification is getting higher, and I believe that which will be cheaper. So eventually SSD will cover the more part of the storage, but still I believe both hard disk drive and SSD will cover. So today we are going to see what is the I/O devices. Then our goal is not such a hardware specification. So in this class, this is operating system. How to use that hardware for what? As a part of an operating system, which means mostly data structure. How we don't have to worry about the different media like the SSD or either the hard disk drive, but in terms of the operating system data structure, it's nothing. There's no difference. So we will see how to manage such a thing, the I/O devices. Okay. Can you imagine? It's a 6,000, 10 megabyte computer system. But my first computer was the Apple computer. Okay, it was the 1983. So 1983, just after I graduated from the elementary school. It was the 2,000 US dollar at that time. It's cheaper than this, but the 2,000 means in 1983. It's almost I believe the half year salary. Really, in the country. So it was very, very expensive. Still, I do not know why my dad purchased such an expensive computer. I never asked, but he did. I guess because my father worked for the bank, so at that time there was a kind of business. So probably he is the client, the work for such a business. So he need to buy or maybe gift. I'm not sure. So anyway, so it was very expensive. So it started from 6,000, and you can see the 10 megabyte. So I still remember my first hard disk drive was the 100 megabyte. It's bigger than this, but it was very, very expensive. So finally, I can cover all operating system on hard disk drive. It was not. So when I used the computer, the personal computer first time, I need to insert the diskette. Probably you do not know floppy diskette to start the operating system, because the memory itself is not big enough. So I need to, and the hard disk drive is not enough. So I need to use the cassette tape to store the data and so on. So the storage was the problem at the time. And it was getting cheaper, but still there's 1,000 level. But as you can see, why don't you see the inside of a hard disk drive, like this, and like this? It's the same as the current one. There, the basic, the architecture, physical architecture, the mechanical architecture are not changing, but it's narrow and the faster algorithm to search the data. Okay, so we are going to see such the storage media, the mostly hard disk drive versus the SSD. To do that, I have the better slide that this is from the other university I found. So this is I think this. So the comparison between the hard disk drive and SSD. So this you already know that disk is rotate and the disk arm moving is left and right. And so the data I will show you later is around the track. So what we see. But SSD is nothing but a bunch of the bank of the flash memory. So that's it. So it's very simple. And so when we see the hard disk drive, when you purchase the hard disk drive, what do you check? So capacity. And capacity will be determined by what? Number cylinder. So cylinder is how many, the set of track. Okay, so the track is on one platter. Okay, we will see like this one is a track. Okay, and when we have the number of platter, it's the same track position is called the cylinder. So number of cylinder determine the capacity. Another thing you need to check when you purchase a hard disk drive is the RPM. So RPM is usually, if you drive, RPM means engine speed, rotation. So number of rotation per minute. So which means the 15,000 RPM means 15,000 rotation. So it's a spindle. It's extra to rotate the platter. How fast? It's a 15,000. Wow, so fast. So per second you can divide by the 60. It's still the several hundred the rotation. And the same time this column is moving the left, and you can see that this one is moving this one left to right. Then we can find the exact any position of the platter to read the data. So this is the hardware. So you can check the number of cylinder and the. So this time the track is this, and this is called the same angle. So sector size may be various, like this outsider, outmost, is the wider and bigger, and the inner is smaller. So we are not going to, from the operating system point of view, we are not going to use this, not the identical physical structure. Instead, we are going to define the new data structure on top of track and cylinder that is called the logical block addressing or logical block number. Sometimes it's called the LBN or sometimes LBA. It doesn't matter, it's the same thing. LBA means, so instead of the track, so we define the same size of the data structure, which is called the block. If you are taking or took the database class, we talk about the block. Block is what? Always in computer science, when we talk about any block, block is the I/O unit. When we transfer, when we read, when we write the data, there might be certain basic unit, that is the block. So always we are going to write the data as a one block. Even though I write the one bit of the data, even though one bit, we are going to write one block. Okay, fixed size. And also when you read the data, when you transfer is a little bit different. But it's like the network will be packet based. But it's also based on the inside the block. So block will be used for the I/O unit. So we are going to operating system use such the LBA or LBN. So that is from outside, from outermost. It will cut by what? Depends on the block size. The operating system use 512 byte, and mostly the block size is the multiplication of the OS block size. Okay, so 0, 1, 2. So from the operating system doesn't have to know the cylinder number, track number, and so on. Instead, only 0, 1, 2, such a LBN number or LBA, the address. Then who convert LBA to so operating system know only the logical block address to 0. Then who knows where this 0 block is located? Who knows? We don't care. Disk controller. So disk controller has knows how your device is organized. So interrupt. So CPU would like to read the data, logical block 0. Then the interrupt then send the signal to the disk controller. Then disk controller receive the logical block 0, then convert into the physical address. The disk number, cylinder number, track number. Finally, by rotating and moving, access the data and return. Keep the data in the disk controller. Then disk controller also interrupt the operating system, send the data to the memory. Then finally CPU read the data. That's what we will discuss later in the more detail. So this is the LBA. What about the CD-ROM? So have you ever write the CD or DVD? If you write the movie or the music, you may feel something different. The written part, unwritten part. Is it out to inside or inside to outside? It's different. So mostly the CD use inside to outside, but the hard disk drive is outside to inside. Okay, so that is the hard disk drive. Then they are connected to the interface. So there are a bunch of different types of interface, okay, connector. So SATA, you probably see a lot the types of when you purchase a hard disk drive. So you probably see the types of the interface. So SATA, it's a serial ATA, most popular one. So their speed is right now up to the several hundred megabyte. Okay, so in terms of in terms of bit, it's a giga. Okay, several giga the bit. so 8 times. Okay? And the PCI and so on. So this is not the computer engineering class. So we just look what is this, okay? But if you are interested, or if you are from the engineering or computer engineering, so these are the things you need to understand: the specification and input and output, and so on. Also, if you develop I have the new device. I try to develop the new device. For example, when I worked for the bank as a database administrator first time, one of the Unix administrator manager, he developed kind of the new interface for the console, which means each IT department has several hundred different server computer. So if you upgrade the system, you need to log on the system through the console, then update everything. So tedious. So what he developed is using serial port. Because serial port is connect the primary port to connect the system as a console. So mostly the administrator job. So a lot of console then connect to the one device. So he developed actually design and make the fabrication and so on, the one device. So one time, so if you type the login, then up to the 18, 24 device connected at the same time. It's not very difficult. It's just one command, then from the device connected. So at the time he used the serial port. Each serial port pin has the specification. So you can use the specification and develop the device and make the program that can be done in the computer engineering part. But we are in the operating system. Don't worry about too much. But if you are interested in the so, however, there is a latency. Latency means the delay time to read the data. Hard disk drive a lot. SSD almost not, because it's nothing but the memory. Regarding to the hard disk drive, there are two types of the latency. One is the rotational time. As you imagine, the platter is rotate to find the proper location. Another one is the seek time, because this one is moving left. Even though we find the proper sector position, but it should rotate, either it should move left or right to find the proper location of the data. That is called the seek time. The seek time latency and the rotational latency. Okay. So regarding to the architecture, SSD, so there's the interface connector. So you mostly use SATA, it's a serial ATA. Then it's the flash memory. So like the combination of the flash drive, so will be used. So then very simple. Almost a zero, the seek time, the benefit of using SSD, and very fast, okay, and very low burst, so in terms of the hardware, okay? And this is a real benefit, no moving part comparing to the hard disk. So hard disk drive is rotation and seek time, the moving arm and moving forward and backward, left and right.